Hello, Stat 300, and this is Professor Gonzalez, and I would like to do some problems from our Stat 300 review for test number 3. So this first problem says, find the shaded area under the standard normal curve. So these values right here are z values. This is the standard normal curve, so these are z values. And we are able to look up these values on the z table. So what we want to do is we want to take a look at this negative 2.25. Of course, what we do, and maybe I'll skip this part in the future on other questions just to keep it rolling, but let's look at this one. We take a look at the z table, and it is on the negative side, so I'll go to this negative z table, and I need to look up negative 2.25. So I look up negative 2. Here's negative 2.2, and then we go up to the hundredth position, which is 5, and this gets us to negative 2.25, and that tells us the area to the left of that z value. So let's go to the picture. That is what 0.0122. So let's go up to that. That means that this area right here is approximately 0.0122. So we're interested in finding the gray shaded in area. So this will help us in a second. Let's go ahead and take a look at this z value of negative 0.35. So let's go ahead and take a look at that. Still on the negative side, negative 0.35. That's down here at negative point. Here's my negative 0.3. And then once again, 5 is right here. So we'll come down all the way to negative 0.35. Okay, so negative 0.35 gives us an area of 0.3632. Okay. .3632. All right, so let me go ahead and go back to my original problem. So that means the area on this one. Now this is the area, this is sort of the tricky part. Remember, it's the area to the left. So this area is going to cover all the way from that point to the tail. And that area is 0.3632. So now for the grand finale, if I want this sort of gray area, that's what I'm really interested in, I need to take the green area, the total area from negative 0.35 to the left, right? This total area is 0.3632, and I need to subtract out the blue area, which is 0.0122. And when I subtract those two areas, the green minus the blue, it gives me the gray. And that gray area is 0.351. So that is our area, 0.351. That's the area of the shaded region. Okay, question number two, it says, it gives us a sample size of n equals 45 has a sample mean of, and they give us the nice notation there, sample mean of 56.9 and a sample standard deviation of little s equals 9.4. So notice this is a sample, and they give us a sample size, okay? So we're supposed to, what we want to do is we want to construct a 99% confidence interval for the population mean. Now, the thing to note here is that this is a sample, and we have the sample standard deviation. We do not have the population standard deviation. So this means when we look at our formula sheet, instead of knowing the population or population standard deviation, we know the sample. So we're going to use this formula right here. Let me go ahead and copy this and bring this to our problem. And copy. bring it to our problem. And it didn't paste, didn't cut it out. That's interesting. Okay. Well, that's okay. I know what that is. So let's organize our information. What we need is a point estimate. We do have a point estimate already figured out for us. That point estimate is going to be our sample mean, right? That's our point estimate. We need to figure out the margin of error. And the way we figure out the margin of error, first piece of that would be that we need to figure out the point estimate. Now, when you look at this formula, the point estimate actually is a t value. So, I'm sorry, the critical value is a t value. So let's take a look at that real quick, because that was an area that a lot of students sort of messed up on when they were doing this review, because they used a z value. And the thing is, this is a t value if you take a look at the formula. Unfortunately, that formula did not copy when I tried to move it on over here for some reason. Let's go back and look at that real fast. First of all, thing to notice is this confidence interval for the population mean, but this is when the standard deviation of the population is not known, so we use a sample. The other thing to notice is, look at that. The critical value, the critical is a t value. So let's take care of that now. So when I take a look at this, we're looking for a 99% confidence interval. So if the confidence interval was right here at 99%, right, what's left out here are the tails. So that means our alpha is going to be the leftover, right? We're going to want to equal one whole, or think of it like a dollar. 99 cents plus 1 cent makes a dollar. So that's the full area under the curve. But we really just want half of that. We want half the alpha, which half of the alpha is 0.005. When you cut 0.01 in half, that's what we get. So this is the area to the right, and that critical value that we want, t sub half of alpha, is going to be right there. Now we have a great chart for that. The other piece that we need to know is we need to know the degrees of freedom. Now the degrees of freedom are always going to be one less than our sample size. Our sample size is 45. So our degrees of freedom are going to be 45 minus 1, 44. Degrees of freedom 44, area to the right, 0.005. Let's go to our t distribution, not z, our t. Now if you take a look at our t distribution, you can see it says area to the right tail. We want that to be 0.005. So we come down here, and degrees of freedom happen to be 44. The rule here is, where am I at here? 44 is right in between. So if you don't see your degrees of freedom on the chart, you always go to the more conservative route, which is drop that degree of freedom down to 40. You always drop down. If you don't see your degrees of freedom on the chart, you always drop down. If you hit 200, or actually more than 200, then we use a Z. All right, so then we come over here, we're using degree of freedom of 40. We're coming down here at an area to the right tail is 0.005. We're gonna, whoops, and that had to do that, of course. Let me zoom back in. And we're coming down the chart, oops. Coming down the chart, here we go. Where is it gonna connect up? There it is right there. So our critical is 2.704. 2.704, let's get back over here. Now we can see our critical value is 2.704. Now, the other piece we want is our standard error. Okay, so our standard error, well, the standard error equals what? Standard error is going to be S over the square root of N. Well, our S value up here we can see is 9.4. So we've got 9.4 divided by the square root of our sample size, which is 45. So we go ahead and divide 9.4 divided by the square root of 45, and we get approximately 1.401, let's go one more place, 1269, so go up to 7. That's our standard error. So now the next thing we want is we need to know our margin of error. Let me bring the margin of error over here. Our margin of error is going to be equal to, remember, it's going to be, let me show the formula, our critical, not z, sorry about that, our critical is t sub half of alpha, and that's going to be times our standard error. All right, well, we know those values. We know the critical is over there as 2.704, 2.704, and that gets multiplied by our standard error, and our standard error is 1.40127. And we go to multiply that, and that's going to give us a margin of error of approximately 3.789, at least to 4 places. I'll go to 5 places. Okay, now let's go ahead and go in for the actual answer. Remember, our confidence interval is going to be found by taking the point estimate, which is, we're trying to figure out the population mean, so our next best thing is our sample mean. So that's considered the point estimate. Our point estimate is the sample mean at 56.9. So it's 56.9, and we take minus the margin of error. Minus the margin of error. What's the margin of error? 3.78903. We're trying to figure out or get our interval. So that value right there is going to be less than our mean, population mean, and then we need to find the upper bound, which is going to be our point estimate, which is 56.9, and then it's going to be plus that margin of error. Margin of error is this brown value here at 3.78903. So we subtract the 2 on the left, which gives us approximately 53.11097, and over here we get approximately 60.68903. So our confidence interval is going to be 53.1. So mu is greater than 53.1 and mu is less than 60.7, and this is at a confidence level of 99 or 99% confidence level. And we got that one done. Okay, next one. We're taking a look at smartphones. And let me zoom out so I can see the whole problem. Let's see. Looks like we have these smartphones. Well, smartphones. There we go. Among 243 cell phone owners aged 18 to 24 surveyed, 105 said their phone was an Android. Okay, find a point estimate for the proportion of cell phone owners age 18 to 24 who have an Android phone. So we're looking for a point estimate for a proportion. All right, well, we know the point estimate for a proportion is going to be p hat, and that is we take our x value divided by our sample size. Well, our sample size is right here. That's n, and right here is our x. So construct, let's see, part A, we're looking for that point estimate, so it's p hat. That p hat equals 105, and then a sample size of 243. We divide that, we get approximately 0.432. There's our point estimate, also known as our sample proportion. Second, we want to construct a 95% confidence interval for the proportion of cell phone owners aged 18 to 24 who have an Android phone. All right, well, we've got a point estimate. Now we need to come up with our margin of error. I did make a copy from our formula sheet. Our margin of error is right here. The important pieces to find is what? A critical. We need to get a critical value. We also need to get the standard error. Okay. Let's go ahead and get the critical value over here. I'll do that in purple. I want my critical value. And when you look this up, when you look up a confidence interval for a proportion, you're going to see that the critical value is a z, unlike the last confidence interval where the critical value was a t value. This is a z value, and z values are awesome to find critical values because we just look them up really in a quick way. 95% confidence interval. Let's take a look. Let's go ahead and look that up on our formula sheet. 95% confidence interval. We just take a look at this guy right here. 95% confidence interval. Oh, there it is. That critical is going to be 1.96. Perfect. Okay, 1.96 is the critical. That's important. The other piece we're going to need to find is this standard error. We'll do that right here. All right, let's see, I'm trying to save space. So standard error. I think I'll zoom in a little bit. So standard error, well, that's going to be p hat. Remember, p hat was our point estimate that we found earlier. I'll go ahead and make that in red since that's what color I used before. 0.432. Then we need to multiply by its complement. So 1 minus 0.432 is going to be 0.568. Then we need to divide that by n, our sample size, which is 243. And then that needs to be, don't forget it, square root. Okay, when we do all that, we're going to get our standard error to be approximately 0.031777, right? And that goes on and on. Anyhow, let's go ahead and get our margin of error. I think we can do our margin of error over here, trying to save some space. Margin of error, that is going to be the critical value. We found the critical value to be what? 1.96. And then multiplied by the standard error. That standard error happened to be 0.031777. Go ahead and multiply that. And we get a margin of error of approximately 0.06228. Of course, how do we get our confidence interval? No problem. We start off with our point estimate. This was a p hat, right? So our sample proportion. And let's start that over here. That's going to be 0.432. And we must subtract that with our margin of error. So point estimate minus margin of error. Where's our margin of error? It's right here. I wonder if I can cheat and just, this isn't cheating, I'm just saving time writing, and I don't really know if I'm going to save much time doing this, but if I copy that and stick it right there, hey, that worked out okay. And then I'm going to take, what am I finding? I'm finding the population, I believe. Construct 95% confidence interval for the proportion. So this is the population proportion of cell phone users, such and such, so-and-so, or whatever it said. How old are they? I guess I should say the whole thing. Population proportion of cell phone users aged 18 to 24 who have a what? An Android phone. All right, so then getting back to this, finishing this off, our point estimate, which was 0.432, and now it is plus the margin of errors. So I think I can just do that, and that was the benefit of copying that. Okay, let's finish this off. I'm so zoomed in I really can't see everything, but that's okay. When we subtract the 2, we end up getting 0.36972. When we add the 2 together, right here, we get 0.49428. So let's make our confidence interval and round to 3 places. That's 0.370. And the upper side of things are 0.494. Let me redo that. Let me redo it all. 494. This is our confidence interval, and this is at a what? At a 90, where I'm going back to it, at a 95% confidence level. All right, so there's our answer. Then they asked, I think they had one more question, so let me zoom back out. And why did that go away? Let me zoom back out. I just lost everything. Not everything, but I lost some of what I wrote. The box. No, I lost a little more than that. At a 95% confidence level, that's all I lost. Let me try that again, put a box around that. There's my solution. Part C had a little bit more to it. Part C says, assume that the advertisement claimed that 41% of cell phone owners aged 18 to 24 have an Android phone. Does this confidence interval contradict the claim? Okay, this confidence interval does not contradict. This does not contradict the claim. You know, I think I'm just leave it at that. I could restate the whole thing again. I'm probably supposed to. But let me say why. Because why does it not? Because 0.41 is contained in our confidence interval. All right, so that takes care of problem number 3, and we will continue. I'll do this in pieces and parts